Welcome everybody to this session. I think most of you know me, but in case there's anyone here that doesn't, I'm Penny Williams. I'm the co-lead of Program 5 in the Australian Cobotics Centre, which is the human robot workforce. And joining us for this session today is Dr. Claire Mason. So Claire is also an associate investigator of Program 5 and the co-supervisor of one of our PhD students. But Claire's going to talk to us today about the work that she's been doing in her role at CSIRO's Collaborative Intelligence Future Science Platform, or otherwise known as CINTEL, where she leads the skills component. And CINTEL partners with the Australian Cobotics Centre. So this is a Horizon 3 CSIRO-wide research program that Claire's going to discuss with us, and it focuses on the science of human-AI collaboration. And their definition of collaborative intelligence encompasses both cyberphysical, so things like cobots, and virtual collaborative AI systems like generative AI. So Claire will today provide us with an overview of some of the use cases of collaborative intelligence at CSIRO, and then she's going to share some findings from the skills team, which have been exploring what competencies workers need to collaborate effectively with AI systems. So a lot of this work is very relevant to some of the research that we're exploring in the Australian Cobotics Centre. So I'm sure there'll be a lot we can learn today. So I'm going to hand over to Claire in a minute. But Claire, I didn't ask, would you like people to put their questions in chat for you to answer at the end?
Sure, or feel free to jump in. I don't mind either way.
Okay, that's great. So I will hand over to you now, Claire. Take it away.
Thank you, Penny. It's a pleasure to be here today. And I have to admit that a lot of what we do in the skills project for the Collaborative Intelligence Future Science Platform overlaps a lot with what Penny's team is doing. And when Penny presented Program 5's research agenda to the CINTEL FSP, I went, oh gosh, Penny's doing it all already. So I hope there's some novel work in here. I'm not actually going to be talking much about what our collaborative intelligence use cases are in the CSIRO, because I was informed by Cecile Paris that she's already shared that with you guys. So I'm going to concentrate primarily on what we've learned so far from the skills project's work. So I first want to acknowledge that this is the work of a lot of people. I'm just the one who gets to talk about it today, and I'll be sharing citations for relevant research papers as I go. But effectively, what we're all focused on is the potential to achieve a step change in performance by harnessing the complementary strengths of human and artificial intelligence. And what we're talking about here is a shift from the really traditional way of working with AI, in which we've only ever been able to give AI a very prescribed set of inputs that the AI is trained to deal with and use to produce a very prescribed set of outputs. And the result is that the AI has only ever been able to support our work on a very specific task within usually a specific GUI or device or app, whereas as human beings, we have to complete our work across many different types of tasks, often across multiple environments, online and real world, within a given day. So up until now, AI has been powerful, but hasn't been able to come with us on the journey of completing a full task. And instead, we've been doing a lot of fixes and, using the input from the output of one AI in a larger piece of work. What we believe is that the developments in fields of artificial intelligence, fields such as dynamic situational awareness, natural language, and computer vision, mean that increasingly these AI tools are going to be able to collaborate with us on a shared task in the way that another human being might do. And that means we can now design the AI to complement us over those different stages of work. So here's a very basic schematic view of how we're thinking about the complementary strengths of human and artificial intelligence. And obviously, strengths and weaknesses of AI is something that's changing over time. I wish I could say the human intelligence was also evolving and maturing, but I'm not quite so sure after the US election. But putting that aside, fundamentally, AI is great at performing data-intensive, repetitive tasks where they have well-defined boundaries, and it can be consistently accurate on those tasks and deal with a much larger volume than any human can deal with. Humans become fatigued when we're dealing with repetitive tasks, and our accuracy tends to be impacted by things like cognitive biases and social pressure and influence. So in those ways, we're quite complementary. The AI can do things that humans are not so good at. On the other hand, the AI is not good at dealing with unknown or novel situations. That it doesn't have good manual dexterity, and it's really not as good as a human at processing input from multi-sensory sources. So those are the strengths that a human can bring to the collaboration. And we're arguing that if we design the AI and the human to work together in that complementary way, that's how we're going to get that step change in performance. So we had this concept. One of our first pieces of work was to do a systematic literature review to see if any AI systems currently out there illustrate this potential. And we carried out that review back in 2023, I think it was. So it's a little bit out of date now. The generative AI tools weren't out at the time. But I think it's worth sharing just two examples that came out of the literature review because they really serve to illustrate the sort of future way of collaborating with AI that we're interested in. So most of the examples we found were prototypes rather than things that were in widespread use. But importantly, they were being used across a wide range of domains. So this one here called drone response, which came out of a university research project, was developed for search and rescue teams. I'm going to share another one that's developed for healthcare teams, but we've seen examples for knowledge workers, for manufacturing work, assembly work, quite a wide range. But as I said, not yet in widespread use. So to illustrate why we consider this one collaborative intelligence, it's because we can see the collaboration between the human and the AI happening across all stages of the search and rescue. So in the first stage, a human research team at a control center is notified that somebody needs rescuing, and they provide the contextual information to the AI system, which controls these drones, but are then able to go out and search over a much larger location much more rapidly than any human response team could do. And they're continuously streaming back imagery of what they're seeing, and they alert the human response team if they find a person that they think could be the person needing assistance. But it's actually only the human response team that has sufficiently good, I guess, contextual knowledge and sensory intelligence to actually go, yes, that's the person we're trying to identify versus no, that isn't. So together, the drone and the human response team are able to locate the person needing assistance much faster than they would have without the drone assistance. At that point, it becomes a different collaboration, but still human and drone response team working together. Because having located the person needing assistance, the drone becomes the eyes on the scene that the humans can direct around the person so that they can understand the potential risks, the possible access routes to get to them, and the health status of the person and what kind of assistance they might need. And at that point, the drone not only streams that information back to the human, but they can also bring in more rapidly things like flotation devices or maybe food and water that can help the person stay alive for the time that it takes the human response team to get there. And then at that stage of rescue and recovery, we're relying on the humans with their much better multisensory input and dexterity to bring that person to a place of safety where they can be looked after. At that point, there's still potential for the AI system to support the human rescue team by, for example, digging out information from a person's health record about what kind of treatment or support that individual might need. So that's one illustration of what future human AI collaboration might look like, and that's a cyber-physical one. The next one I'd like to share is called SAGE, and this is a purely virtual AI system that collaborates with a human care team. So in this case, SAGE is a patient management system, and its job is to help human carers to more accurately diagnose and treat a person. So that's the shared objective. The AI does not provide the initial diagnosis. That's done by a human physician. At that point, the AI just receives all the same data as the physician. And its job is to identify any data that's anomalous with the diagnosis that the physician provides. So it's about using the AI to do that more comprehensive and consistent data search to draw out things that the physician might have missed due to lack of sustained attention and their inability to deal with the same amount of data, or potentially even a bias. And that AI system can ask questions and draw the physician's attention to that anomalous data, but it's still up to the physician to determine the final diagnosis and come up with a treatment plan. But even after that diagnostic stage, the phage system is still collaborating with the care team because its job is to continue to monitor the stream of data relating to the patient's condition and improvement, and notify the care team via this pretty user interface of the flower when things are going on that aren't in line with the original diagnosis and treatment plan. And what you can see here is this lovely, very user-friendly interface where initially the plant's growing straight up because everything in the data is going exactly as you would expect based on the diagnosis and the treatment plan. And then all of a sudden the flower's gone sideways because something's happening and the care team needs to be alerted to the fact that it doesn't look right anymore. Things aren't going as expected. And the petals, those black petals, I believe, are allowing the care team to click on the petal to see what's going on in the massive stream of data behind that patient that looks wrong and is causing the AI system to say something might be wrong. So here again, you can see they're very much designed to complement each other, the human and the AI, to support a shared objective. And so that brings us to how we define what collaborative intelligence is. And I should admit that collaborative intelligence is just one label for it. Other people call it collective intelligence, human machine teams, hybrid intelligence, hybrid teams. For us, it's what you've got if humans and AI are designed to bring their complementary strengths so that you're achieving better performance or more than you could have with one of those actors alone. They're actually working on the same objective. They have a shared understanding of what's happening in that situation. So, both the drone and the Sage system understood when you switched from having located the person or diagnosed the person's condition and onto a different stage in the team. And there's a form of sustained interaction between the human and the AI. That interaction might be words, it might be mouse clicks, it might be a cobotic arm being moved around, but some kind of ongoing interaction so that it's not just the human giving the AI some input and the AI delivering an output, but the human then providing feedback on that output and the AI can adjust in response so that they're each feeding into each other's work. And the ultimate product, you can't go, oh, the AI did this bit and the human did that bit. It's a joint product, just you would have if you were dealing with a pure human team. So our job in the skills project was to focus on what human skills are needed to maximize the effectiveness of this collaborative intelligence team. So there's been a huge amount of work looking at how we can design AI systems so that they can collaborate with humans, so they can understand the shared objective and the situation and communicate with the human. But the human's also going to have a role in determining how effective this team is. And our job is to understand what specific skills a human needs to collaborate well with artificial intelligence systems. And this is a really lame joke that I came up with in collaboration with ChatGPT. So let's blame ChatGPT. But what I'm trying to illustrate here is that, yeah, we can have these amazing AI tools to accelerate scientific discoveries and other types of progress in human society. But if the human person who's using that system doesn't understand what we're trying to achieve and how the AI works, they're not actually going to achieve their end goals. So what kind of knowledge, skills, and aptitudes do humans need to work effectively with cobots and Sage and drone response? Unfortunately, there's not a lot of examples out there of people actually using truly collaborative AI systems. But what we have done is leaned very heavily on generative AI tools because there's something that's been very rapidly adopted. And they do have this capability of understanding a human's goal and responding to feedback from the human that allows them to refine the output so that ultimately you're getting more productivity or a higher quality output through working with the generative AI than you might have been able to achieve on your own. So we're calling that a sort of early example of collaborative intelligence, and we're using that to explore these questions. And what we have done is come up with, those defining characteristics of what is collaborative intelligence and use that to come up with some propositions about what we expect could be different. And we have a different researcher addressing each of these propositions. So, as you know, one of our core propositions is that we're using artificial and human intelligence in complementary ways. So the AI is being used to perform tasks that might have been difficult, dangerous, or dull for a human worker. So it's providing some kind of capability. It might be physical strength, it might be knowledge of a specific coding language, it might be sustained attention that previously only a relatively small group of workers had. So one of our propositions is that collaborative intelligence may mean that more people can do a job than previously could before, that we can enlarge the talent pool. And one of our questions is, does that mean we're upskilling our workers to be able to do a wider range of tasks because they're augmented by this collaborative intelligence? Or are we potentially de-skilling workers because they're now leaning on the AI and we don't have the same depth or breadth of human expertise in the role? So that's something we're looking at with Yijing Lau and the team at Curtin University and Swinburne University. The second thing we know is that there's going to be a lot more time spent by the human interacting with the AI because we've got this sustained interaction where it's ongoing feedback from one to the other. So we're predicting that the ability to communicate or interact, guide and direct the AI appropriately is going to be increasingly important for good performing AI collaborators, if you like. And that's one of the areas of focus for Dr. Einat Grimberg, who's one of the postdocs working in the Skills Project. We're also expecting that we'll have a lot more choice about how and when to use these AI systems. They've got the flexibility to come with us across different stages of a task. So therefore, a human's going to have to make choices about when we go to the AI and when we do things ourselves and what's appropriate to delegate. So we're arguing that AI literacy, understanding the strengths and weaknesses of the AI will be critical, but we're also pushing the notion of metacognition potentially becoming increasingly important for human workers. And I'll explain why that's become an important focus for us. And then finally, and not least, we have Fung, who's part of Program 5 and working with Penny and Greg and me, who's looking at once we're bringing cobots and potentially other forms of collaborative AI into the work environment, how does that affect aspects of our work that humans typically find intrinsically motivating? Things like having autonomy, having the variety of tasks, having social connection. How do we ensure that when we implement these collaborative AI systems and cobots, that we maintain those aspects of work that humans find motivating so that we're still getting optimal performance, satisfied workers, not high levels of turnover, that kind of thing. So that's the big picture of the work our project is doing. And now I'm going to hone in a little bit on what Sidra and Einat have been doing just to give you a sense of the latest findings. So for Sidra's work, she's very much drawing on existing research, which points to the need for AI literacy when working with artificial intelligence. And that's competencies to critically evaluate AI technologies. So it means you need to have some understanding of how AI perceives and learns. Normally teaches you something about the different types of AI tools that exist, what strengths and limitations they have, how to interact with them, and what impact these tools can have when they're used in the real world, biases that they might create. So that's typically understood to be important for working with AI well. Sidra's proposition is that metacognition is also going to be vital when you're working with these more collaborative AI systems. Metacognition is the ability to think about your own thinking, and it comes in two ways. One is the ability to think about your own thinking, having awareness of what you're good at, what you're not so good at, and different strategies that you can adopt. So it's really getting out of the doing and going into the headspace of being more mindful and aware of how to approach the task best, given what you know about what you know and what you can't do so well, and different strategies you can adopt. And then it's also the ability to regulate your own cognition, to be able to choose to spend some time planning how to approach a task, to pause and monitor whether what you're doing is working and how you might improve it, and evaluate how things went and what you might do differently. Those are all metacognitive processes. And why we think metacognition is going to be increasingly important with these collaborative AI tools is because traditionally humans rely on cognitive heuristics or biases or rules, these mental shortcuts that allow us to make decisions despite of having limited information and limited time. So for example, typically all of us make decisions about who to assign a particular job to. And we do that based on our understanding of person A and person B, what we've seen them doing in the past. Person A was good at this type of thing before, so I therefore think they'll be able to do the new task better than person B. That's called a halo effect, where we use what we do know about a person to infer whether they'll do something else, maybe similar, maybe not so similar in the future. And that rule works quite well because humans have general intelligence, which means we do well on most things or related things. We're sort of consistently good. And AI does not have general intelligence. It can be incredibly intelligent for one type of question and then fail miserably, and a 4-year-old could perform better on the task just because you've changed it slightly. So if we rely on that existing cognitive heuristic, instead of being metacognitively aware, we're going to make poor decisions about what an AI can do. And similarly, another technique we use when dealing with too much information, which is most of the time these days, is an anchoring technique. Rather than just going out there and examining all possible solutions, we tend to anchor on the most relevant information we see in the first place and sort of keep going from there. But if we do that when working with AI, then we're failing to add value to the AI. The AI will give us a response. If we let that guide our thinking from then on, then we're not adding the unique value that we need to provide as the human collaborator. So those are that's one reason, is we need to be less reliant on our typical cognitive biases and more metacognitively aware. Another reason, though, is that when we work with another human, we get unsolicited feedback, sometimes welcome, sometimes not, and support. Like if your co-worker sees you making an error, they'll probably jump in and tell you. If they see you're really busy at the moment, they probably won't bother you with the detail. AI as a collaborator is not going to do those things unless it's specifically trained to do it. So you now have to be more self-managing, more metacognitively aware about, well, am I looking for disconfirming information? What might I not have thought about? And that's a metacognitive process. Another reason why we're going to need to be more metacognitive is the AI can do the things that we already know how to do. That means the human's going to be given the novel problems and the novel context to work in. And that's exactly where metacognitive thinking adds value. We can't rely on automated thinking when we're in a novel context. And finally, AI can't do metacognition. AI isn't self-aware, so therefore it can't think about its own thinking. So this is one of our unique human attributes through which we add value to the collaboration. So based on this theorizing, which we published in a recent paper, we've got now a training intervention that we've been delivering internally for some of our researchers who are upskilling to do more data science work. So there were previously people who worked in the field, and they're being given training in things like using R and Python and accessing data via APIs. This is a 12-week intensive course. And in the 11th week, we deliver training on how you can use generative AI tools to do data science work a lot faster, potentially do things you might not have been able to do before, learn about new techniques. What we're doing is initially testing their data science skills at the start of the week. then they're randomly assigned to either get a combination of generative AI literacy, so just a little bit about generative AI tools and how they work, and metacognition training, or the other intervention is pure AI literacy and generative AI literacy. And then at the end of the week, we assess them again. They've had time to practice working with generative AI tools and using metacognitive techniques, or reminding them of AI literacy information. We look at whether which of those two groups is actually working best with the generative AI tools at the end of the week. And the reason I have a QR tag on here is because we've been funded to deliver a much shorter, we're hoping we can do it, condense it into 2 hours version of this training for early and mid-career researchers. So if you're interested, do please scan the QR code and sign up. And hopefully also you might be willing to share your data for our research, because at this stage, we only have informal feedback. The informal feedback we've had from the 2 cohorts that we've worked with so far is they're just so excited about how AI tools expand what they can do, but they also really appreciate the need to be aware of its limitations. I don't have a clear sense yet of whether the metacognition or the AI literacy training is going to be more effective. So I'm looking forward to discovering. The other work I wanted to talk to you about is led by Einat Grimsberg, and she decided to adopt a more grounded approach. So where Sidra came through with, we know about AI literacy and metacognition, Einat wanted to go back to the basics. One of the things she picked up on was there's been this huge emphasis on AI literacy and prompt engineering as how you work with generative AI tools. Her theory was maybe there's some broader underpinning knowledge or skills or aptitudes that might be important for using generative AI tools well. And to explore that question, she deliberately adopted a purposive sampling approach to identify people who were expert users of generative AI. So what we did was we went to websites for professional bodies and looked at the conference programs to identify who'd been speaking about the use of generative AI, whether it be in design work or in social work or in law. And we contacted those people and asked them to take part in the research. And then we also relied on our own professional networks to ask people to nominate someone they knew who was using generative AI tools really well. Because the goal for us was not to understand how to use generative AI for data science, but more what are the generic competencies that apply across different occupational roles, across different sectors, that allow people to use these tools well. And then in the interviews, so we got 25 experts to take part in these interviews. We got them to describe examples where generative AI tools had been used really effectively and less effectively, and then honed in on what competencies underpinned the cases where the tools had been used more effectively. And there are a couple of propositions we wanted to test. One was, are there consistent themes around what more effective use of generative AI looks like, regardless of what domain people are working in? And what are the competencies that are seen to underpin that more proficient use? So here's what we learned about proficient use. And it's interesting to see that prompting actually came out as an indicator of proficiency rather than the underlying skill. So proficient users are good prompters. That is, they know what kind of information to give to the generative AI to get a fast response, so to be more productive with the generative AI, or to get output that's more appropriate for whatever it is you're trying to do, so higher quality work. Proficient users were also very much making informed and responsible choices. So ineffective use might be throwing any data at all into the generative AI and asking questions about it, whereas an effective user was informed and knew not to share data that was, for example, potentially commercializable or private and confidential information. And they were also making responsible choices, like checking that the information the generative AI tool gave was validated in other sources of information, because they're aware of things like the potential for hallucinations to occur. So that was important for the quality of the work you do with the generative AI. And then these more effective users seem to be using a wider range of tools, and they were using them on a broader set of tasks. So ineffective users were just like going to it to answer a few questions and probably not really going into a more sustained interaction with the generative AI, where it's covering different stages of the task, you know, from brainstorming to getting some information, to improving your original draft, to maybe serving as an editor at the end of your work. Whereas the effective users knew the range of tools that are out there and the different ways it could be used at different stages. And then some people were even using these tools in really complex and novel ways, like embedding it within an existing system to expand the capabilities of that system. And so then we looked at what underpins that proficient use. And I think it's really interesting that there were so many different things that seem to go into it, that proficient use is definitely not just a matter of prompting. And I don't have time to go into each of these in detail. I will share a few quotes with you and just add that the information technology skills was not something that people said explicitly, but we did notice that the people who are using the tools in the more complex and novel ways all seem to have backgrounds in software engineering and computer science. So that did seem to be important for that sort of more developer kind of use of generative AI tools. So just to give you a sense of some of these, and the reason I'd like to go into some detail is what I'd like to discuss at the end of this is how much of this applies when we're thinking about cobots and collaborating with cobots. Do we think the same knowledge and skills and mindsets are going to be important in that context, or would it be quite different? So here's what they were talking about. They did not say you need AI literacy. You don't need to understand, for example, the difference between a recommender system and a decision support system. What you need is to understand generative AI tools and how they work, what strengths and weaknesses they have, and what the different ones are and what they're each designed to do. So just as a good carpenter knows when to use a hammer and when to use a screwdriver, a good generative AI collaborator understands when you go to ChatGPT, when you go to Gemini, and what kind of errors or weaknesses the different tools might have. So that's what we're calling generative AI literacy. I also really liked their explanation of the role of communication skills as a driver of good use of generative AI tools. The point they made was that good communication involves thinking about what the person you're talking with needs to know that they don't know already, what order you present that information to them in, what tone of voice you might adopt for one person versus another, or in one context versus another, and how those exact same skills are actually what underpins effective prompting. Thinking about what the generative AI doesn't know that it needs to know in order to give you the right answers or improve what it's doing, and how you can adapt your communication style, that it should be more conversational, not how you search a Google engine, and how you might use it differently in one type of tool than another. Another one was metacognition did come through, but it wasn't necessarily called metacognition. But it was that notion that you need to be stopping and thinking and not just going with the traditional way of doing things, to be using generative AI tools to their full potential. So that first quote is someone going, oh no, I shouldn't be doing this myself. I should be asking the AI. This is a waste of my time. Well, that's that stopping and going out of automatic thinking mode and into metacognitive mode. And then you also have to do that planning around which tool for this task. What do I know about its strengths and weaknesses compared to, say, Claude? And that's why I go to Claude for this bit of the task and ChatGPT for another. And finally, that this metacognition also helps when it comes to evaluating the output of the AI and going, is that actually what I wanted? How might I improve it based on what I understand of the objectives here? So that one definitely came through. We were quite relieved to see. And then finally, what I think was interesting was domain expertise came through a lot. If you will remember that earlier on, I said one of the things we were interested in was whether these generative AI tools could enlarge the talent pool by replacing the need for humans to have certain attributes and knowledge by the AI providing it. But our experts pointed out that you can't guide the AI tools well, nor can you give them feedback well if you don't know how to do the job well in the first place. So for example, as a result of my understanding of data science, I know that I need to tell it things like, how the data file is structured, what the variables are called, what type of comparisons I'm trying to do. That comes from my domain expertise. A graphic designer explained to us that the work of a graphic designer always begins with an idea or concept, and that is still important. When you go to a generative AI tool, you still have to feed it with an idea or concept. And then the domain expertise comes in again with your understanding of the different techniques or effects or tweaks you might make to the original image the AI produces in order to really make it achieve what you're trying to achieve with the work. So it's interesting, while AI might replace some competencies or requirements of humans, it certainly doesn't seem to be replacing the need for the human to know how to do the core job that they're doing with the AI. So that's sort of where we're up to. And what I really wanted to do was explore with you whether some of these competencies are likely to be equally important for working with cobots. We've found that generative AI literacy rather than AI literacy is what you need to work with generative AI tools. Is there a cobotic literacy that we should be talking about and thinking about? And how would we assess cobotic literacy? And then finally, what's different? What else might we need to know about for good cobotic collaboration? I really hope maybe you guys could provide some feedback on that.
Thanks, Claire. That was really interesting. And I've written a bunch of questions, but I would like to just open it to the floor first and see if there are any questions or any responses to the questions that Claire posed to us.
Hey, Penny, I'm
Yes.
happy to go first. Hi, Claire.
Hi,
I'm researching skills as well and cobots, and I've been looking at vocational education in particular and what might be happening in that space. And one thing that's recurring, that comes up in a recurring way, is some base literacy and numeracy skills. And I sort of see that coming through even in that space that you're talking about. Like, it's making an assumption about the literacy and numeracy of people being able to engage with these types of technologies. Is that some kind of consideration that you've got?
We had not been picking up on that, Jacqueline, so it's really great to hear about that. So is that a new thing though, or does that fit under the category of this is domain expertise people have always needed in the role and it will still be important, or is it increasingly important now you're working with cobots?
I think it's increasingly important, and it seems to be increasingly important as people need to gain, when I say higher skills. So if they're looking to move from a maybe a trades role to a technician role where they have to interact in different ways with the technology, there's a demand on their literacy and numeracy skills that they may not have gained through a trade qualification, that then they need to be able to engage with, to be able to engage well, moving into that higher space of operating with advanced technologies.
Yeah, so definitely the idea that this is an upskilling experience rather than a de-skilling experience, that maybe the human worker is expected to take on a wider range of responsibilities and deal with slightly different type of input and output in their job, that therefore demands high levels of numeracy and literacy. That's really interesting. Yeah. So
Yeah.
what are they giving it more focus in the courses these days?
The providers would like to, but I'm not sure how much you know about vocational education in Australia, but it's very constrained in the way that it's delivered.
Accredited training packages are...
And so that's part of the struggle, is that when they discover this, how do they help then support people that need to engage this way? But then I have also picked up on that de-skilling thing, where people are also saying that at points people will be able to be engaging in particular work that might not need a qualification, but then the jump to the qualified work might be a little bit more, if that makes sense. So having to have some more theoretical understanding of what's going on, like if you're talking about a world, understanding the physics and the chemistry of a world in a different way, if there's something that goes on that may not already be taught in a vocational sense.
It sounds like a really important gap to begin addressing. And a lot of people are talking about, how do we deal with the entry roles in our profession now that we've automated what used to be the training environment for a new lawyer or a new, I don't know, accountant. You know, now we got the AI that can do all the document search for us. So how do we ensure people learn the basics to have that domain expertise to guide the AI? I think that's going to be such a huge question. Any answers coming through from the work?
There's a couple of people doing some novel things. So at Swinburne University, they've got a program that they call Ninja Teachers, where they're actually deploying teachers to work alongside the TAFE trainers and they do some gap identification prior. So the students actually don't know that, like they know they've done pre-testing, but they're not given the results. And so they're going into classrooms, and when that particular point is hit in the learning, then the teacher knows they have to work with that particular student, and they work with them in the theoretical sense, but then also when they go into the workshop and into the workspace, they're working alongside them to check that the knowledge is being able to be applied then in the practical sense as well.
Oh, that sounds great.
Yes.
I'm just very conscious of the time, and I know Akash has had his hand up for a while, so I'll let him ask a question. But also, Stina there has placed a couple of questions into chat, and I know that she needs to go soon too. So Akash, do you have are you able to stay on the line another minute or
Yeah,
so?
it's okay. No worries. No worries. Let's read.
Right. Well, we might just post Stina's questions and then go to yours if that's okay. So Claire, Stina's questions were, I'm going to try and read them in terms of the knowledge on diversity of robots. I'm thinking there must be a difference with whether we're talking about robot integration or human robot collaboration. So robots are different in that way because they're integrated into a workspace and then become sort of less customizable, or at least you choose a platform and then people become very familiar with that one. And then the second part of that is, do we need to think of robots as intelligent? Stina says she appreciates the use of metacognition in terms of AI, but robots could also be thought of as just tools rather than having social competencies or perceived intelligence.
The kind of thing that made me go, I think the competencies might be different because there is still less flexibility, less choice. Is that right, Stina? Yeah.
That's right. Yeah. I'm so sorry I have to go now, but I would love to talk more about this stuff at some point, Claire.
But do you think that's something that will change over time? That increasingly people will be using it in less structured and more customizable ways?
I think so. I mean, some of the research I've come across that I thought was really interesting was exactly when you've had someone who's like worked with a specific platform over years and years, and then they sort of like customize it to go along with how their work changes as well. And so it becomes this sort of conversation almost, and sort of adapting the platform. So I would think it would be sort of similar.
Maybe I can connect you both if you don't already have Claire's email.
We already know each other.
Great.
So but thank you so much, Penny. Okay, I'm gonna have to jump out, but thank you so much, Claire. That was really interesting.
Thanks. And just the very last question, because we are over time, Akash.
Yeah, thank you very much. It's a great session and a lot of insights. So I just want to ask one question. So when it comes to the AI literacy, so there's a generational gaps. So now in a workplace, we have a few different generations. So the AI literacy on generation to generation is having a quite different. So what is your idea about to get to consideration on this, your research, and how you are going to address that issue?
Well, I'm not sure my thinking is as sophisticated as yours. I haven't been thinking about it generationally, but my view is that the notion of an AI literacy is becoming outdated. There's too many different kinds of AI for people it to be useful to just think it's one sort of, we can cover it all off, and the different strengths and weaknesses, because they are so different. You know, the way in which you're going to work with a cobot is massively different from how you work with generative AI. And I suspect we need a different kind of literacy for those two things. But what were you thinking in terms of generational differences?
Because the using of now, if you take the new generation like the Gen Z, so the way they are very much familiar with the AI, but the way they use the AI is because you said that we have to create the creativity. You should know the job before you use the AI. So sometimes the problem is whether they know the job. So whether they use the AI for the correct things. So sometimes their creativity might be get impact on the AI, or sometimes their ideas might be getting stuck with the AI usage. So which we have to be managed in a workplace, because we need the people who's having the creativity, innovation, and all. So if AI is going to be restricted, that's going to be a problem in the industry perspective.
Is that an argument for diversity, that not only human plus AI, but we need the experienced human and the less experienced, more potentially flexible human working together with it?
Yes, we have to be
that would be Akash's PhD about diversity and cobots. So I am going to wrap it up because we are 4 minutes past 11. Melinda has left a question for further discussion in our program 5 meetings. Which is, do you think there are many AI literacy and metacognitive skills that can't be formally taught and need to be learned on the job in domain-specific contexts? And I think that's a good discussion that links into Akash's too. So it seems to me that, Claire, you've started a whole other conversation for us to explore. So thank you very much for your time, and thanks everybody for attending, and for those of you that have stayed on a little longer, really appreciate it.
Thank you, everybody. I love the questions and the feedback. Thank you.